Hey guys, today we're going to look at the definitions and examples of pure substances and then of mixtures. So, pure substance is a substance that has definite properties. And we've been through those properties and we'll keep reviewing through those, kind of like a spiral review you do in math. We'll keep looking at those because they're kind of pardon the pun, the building block of everything that we're talking about in this lesson. A pure substance is made up of only one type of particle. There's not two different types of things. So there's not like water and a lemon, okay? It's just one type of particle. Okay, so of course, naturally, every element is a pure substance because we know nothing else is in there. But there are molecules and compounds that are also pure substances because they are the same everywhere you would find them in the universe. And the best example of that is water, because water is the same in Japan as Australia as Marion, Ohio. Okay, it's all H2O. Okay, so just as we've talked many, many weeks, physical changes are not changing their identities. Okay, they are not changing their identities. They will stay the same. Chemical changes, of course, do. Okay, so let's look at this. This is a sample magnified thousands, millions of times of copper. So what would copper be? Is copper an atom or a molecule? What do you think? Well, it is an atom. Okay, because it's an element. So how does this or this picture, either one, illustrate that? Well, okay, it's because all the atoms are identical, row after row after row of the same type of atoms. Okay, now let's look at water. Would water be an atom or water be a molecule? Oops. Well, there we go there. It is a molecule. So let's look at number 15, although the answer already came up. What happens when a pure substance undergoes a chemical change? Well, the bonds, those chemical bonds that are holding together, break apart and you have a new substance. All right, let's look at the last question here. Water is a compound. How does this illustrate that? Okay, it's made up of H2, two hydrogen atoms, and one oxygen, and they are the same the world around. Okay, you will probably see this question on your daily work. So let's think about it. When a pure substance undergoes a chemical change, the bonds are broken and a new substance is formed. All right. We are actually going to skip over these pages. Sorry for the delay. Quite a few. Okay. There we go. Now I want to talk about mixtures. Okay. A mixture is a combination of two or more substances that are not chemically combined. Okay. They do not make a new substance, they stay separate. Okay. They do not have definite properties because they're always different. So let's look at these questions. The student's making is going to make and separate, so he's going to put it together and then bring it out, a mixture of sand and salt. Okay, so let's look at the first question. Sand and salt are poured into the beaker. The result is a mixture because, what do we think? Okay, they don't chemically combine. The sand stays sand and the salt stays salt. A new substance is not formed. Okay, so then we are adding water to it. What do we think then? Well, the salt dissolves in the water, but of course the sand doesn't. So then when the liquid is poured through the filter, what's going to happen? Well, you guys probably know that. You're saying it to yourself right now. Okay, the salt water goes on through, but the sand is filtered out. So we remove the sand. And then lastly, if you wanted to, you could heat the salt water until the water is boiled off, turns into steam, but it would leave the salt behind. So that is demonstrating there that it's a pure mixture, or not a pure, it's a mixture, not a pure mixture. The substances never combine. Okay. And as you can read here, mixtures can be separated by physical changes like density separation, magnetic evaporation. So if you were on the beach, let's say, or on a lakeside, how could you separate rocks and sand? Well, they suggest using a filter that would allow the sand through but leave the rocks out, or you could just simply pick out the rocks. Okay. Mixtures can come into two categories. One is called heterogeneous, and the one is called homogeneous or homogeneous, either one, okay? A heterogeneous mixture is one that does not have uniform composition, so it's not the same throughout. So like Chex Mix that you would eat, fruit salad, a taco, anything where it's different depending on where you are. Okay, homogeneous mixture has substances that are evenly spread throughout and you cannot see them. The examples they give: mayonnaise, ketchup. This is two great examples here. In a homogeneous mixture, it isn't possible to see the different substances. So like mayonnaise, it contains oil, eggs, and vinegar, but we cannot see them individually. You don't see the oil or whatever. But even though you cannot see them, it is sometimes possible to separate them out. We could not do that just in a normal classroom, but it is possible. Okay, then you see like a fruit salad. You could pick out the strawberries, you could pick out the apples, the kiwi, whatever. So heterogeneous is really easy to tell. Okay, then we have a thing, and don't panic, we're going to keep going over these for like a week, but we have a thing called a suspension, and that would be like a snow globe, which I'm getting excited for because it's Christmas time. Suspensions are mixtures in which the particles of the material are spread throughout a liquid or a gas, but are too large to stay mixed without being shaken or stirred. So a snow globe is a great example of a suspension. Okay, and then a solution would be homogeneous. Okay, and that's when one substance is dissolved into another. So air would be an example of that. Okay, then we have one in the middle, and you guys are probably like, all these words. That's a colloid, okay? It's somewhere in between a suspension where you see the pieces floating and a solution. So an example would be Jell-O, okay? So they are spread evenly throughout, but they're small and have a hard time settling out of the mixture. They wouldn't settle to the bottom. All right. This is a graph that I want to discuss, but we're going to do that later in class. Oh, yes, later. Okay, so we're going to stop